KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, here we can see some other examples of refraction. Okay, so this is the example, right? So where you can see the object which is present inside another medium from a different medium. For example, if you see this figure, this is whatever the position of the light, red light, it is like air, which is rarer medium. When compared to the second medium, this is water, right? This example you can also experience in our daily life. That is where by keeping a coin, a 5 rupee coin in a glass tumbler, if you see from different viewpoints, you can feel that the coin size increased, but actually the size of the coin is not increasing. It is illusion, okay? Because of refraction of light, your brain is sensing, right? You are sensing that the size of the coin is increased, but size of the coin is not increased. Similarly, in a glass tumbler having half of pot filled with the water, if you put a spoon and at the point of separation of both the media, that is from air to water, if you observe that, you are feeling that the spoon has bent, but it is also not real, it is illusion, it is virtual, it is because of refraction. So as I told you, two examples. One example is in a glass tumbler having half of the glass filled with water. If you keep a coin at the bottom of the glass tumbler and you try to see the coin from different viewpoints, then you can think that the size of the coin is increased. It is not correct. It is illusion. It is because of refraction of light. Similarly, in one glass tumbler filled with half of the glass with water, and you just insert a spoon and you just see the spoon where the both mediums are separating. Both media are separating from one another. That is from air to water or water to air. There you can feel that the spoon has bent, but that is also illusion. It is because of refraction of light. Not only these two, even atmosphere also. In our atmosphere also, whatever the sunrise you are seeing, whatever the sunset you are seeing, these two are not real. Because of refraction, there is some time gap. After actual sunrise, actual sunset, you are seeing both the images, both the situations. That is what the sunset and sunrise. So which is the example of atmospheric refraction? Okay, right. So now we are going to discuss some of the information about that is because of refraction. See this. It is like a glass slab. Okay, Otherwise, you can imagine as a tub of water having here inside water molecules. Okay, right. Here you kept a coin, right? So the observer, see this. So the observer is seeing from here, right? So in another position, here if you observe carefully, this is the position of the observer. This is the position of the observer. Actually, this is what it is. Here is, this is the position of the coin. Actually, this is the position of the coin that is at O. That is at O. Okay, right. So when the coin is at O, what is the real depth? This is the real depth. This is the real depth. Depth means from here to there. But if you see from different positions, right? Suppose from here, this is the position of the coin you are feeling. By seeing from this position, you are feeling that the coin is here. The coin is here. So what about this? It is apparent depth. It is apparent depth. This is real depth. This is apparent depth. Okay. Actually the coin is here. Nobody came and changed. But because of refraction of light, you are feeling that the coin is here. See this, how the light rays are going. Here also you can see how the light rays are going. Right? Suppose you are seeing from this side means, see, actually light travels along a straight line. Okay? But it bends at the point of separation of both the media. It bends at the point of separation of both the media. So this is the reason, the refraction is the reason. Bending of light ray at the point of separation of both the media is the reason for seeing virtual image, right? Virtual image only, no, right? So whatever you are seeing, whatever the place you are feeling as coin is present, whatever the place you are feeling as coin is present, it is a virtual image, it is not real. Really the coin is here, but you are feeling that the coin is here. That is because of refraction, that is because of bending of light ray when it enters from one medium to another medium. Okay, right. See this, apparent depth for a normal oblique viewing. This is the normal viewing. It is oblique viewing. So if you see normally, you can see as like same position. But if you see obliquely, you can see a different position. Okay, right. Now, atmospheric refraction. Okay, so in our atmosphere, so what I told you already, in case of sunset or sunrise, what happens because of refraction? Okay, see this. For example, the sun is visible a little before the actual sunrise until a little after the actual sunset due to the refraction of light through the atmosphere, right? So we are not seeing actual sunset and actual sunrise. The actual will be different, but we are seeing somewhat time delay. We are experiencing with some time delay in case of sunrise and sunset. That is because of atmospheric refraction. Okay, right. See this. By actual sunrise, we mean the actual crossing of the horizontal by the sun. You see this picture, ma? Here you see the picture. This is the horizontal, ma? It is the earth. Here we are standing. Right? So it is like our atmosphere. Right? So air occupies the whole earth. Right? So it is like a thick blanket of air. Atmosphere is thick blanket of air. Okay. So here it is the atmosphere. So this is the position of the person, right? It is the horizontal. It is you know very well how we are deciding horizontal and vertical. So this is the horizontal. Okay, right. So actually it is what apparent position. This is the actual position. See here. So you are trying to see this, but you are seeing this one. Same like this is what like a coin example. Okay, so you have to see this picture when I am explaining what's happening here. Okay, right. The refractive index of air with respect to vacuum is 1.0000000, right, 29. Due to this, the apparent shift in the direction of the sun is by about half a degree, and the corresponding time difference between the actual sunset and apparent sunset is about 2 minutes. So this is important, for 1 mark bit also they are asking, right? So the time difference between actual sunset and apparent sunset is about 2 minutes. So we are seeing 2 minutes time delay. We are seeing the sunset with 2 minutes time delay. The apparent flattening oval shape of the sun and sunset and sunrise is also due to the same phenomena, right? So what is is it exactly like a spherical shape? Is it like a sphere? Is it like a circle? So what is that? So you know very well, it is like a sphere, okay, but sometimes we are seeing oval shape, okay, so like this, right? So that is also the reason is same atmospheric refraction, okay, right. So from here to here I took 2 different examples belongs to the same phenomena, atmospheric refraction. Sorry, this is atmospheric refraction, this is refraction, okay. So this is, I already told you here 2 examples, that is because of refraction, and this is another example of natural, that is simply you can say that because it's happening in atmosphere, no, that's why we are saying that atmospheric refraction. So wherever the refraction is a natural phenomena, right, we didn't create, it's happening, we are in a discussion, that is the only thing, right. So either in case of a glass tumbler, either in case of a tub of water, either in case of, right, what is that, already we discussed, glass slab, either in case of sunrise and sunset, the reason is only refraction. So when a light ray travels from one medium to another medium, at the point of separation of both the media, it bends. It bends means light ray bends, okay. So bending of light ray when it travels from one medium to another medium, right, bending of light ray at the point of separation when it travels from one medium to another medium is simply said to be refraction, okay, right. Based on this information, now we are going to see one example problem. See here, the earth takes 24 hours to rotate once about its axis. How much time does the sun take to shift by 1 degree when viewed from earth? I'll repeat once again. The earth takes 24 hours to rotate once about its axis. How much time, full stop, how much time does the sun take to shift by 1 degree when viewed from earth? Okay, see here. So time taken for 360 degrees shift is 24 hours. He only given here, right, it is 24 hours. Time taken for 1 degree shift he is asking, right. So 1 degree shift means 24 by 360. So if you do that calculation, it is in hours, so 1 hour is equal to 60 minutes, you know very well. So 24 into 60 minutes divided by 360. So 60, here 360 will give us 6 in the denominator, then it will be 4, 6 here 24. So it is 4 minutes is the answer. So the time taken for 1 degree shift is 4 minutes, okay, right. Now next continuation to the refraction is total internal reflection, okay, right. What is reflection? We discussed in the starting of this chapter. So reflection is the one of the most important property of light. After that we discussed refraction also, but now we are going to discuss total internal reflection. Total internal reflection. Okay, right. So you see this picture here, it is very clear. Afterwards you also see the information when I am explaining, right? See here, when light travels from an optically denser medium to a rarer medium, this is the condition for total internal reflection. Everybody has to remember, when light ray travels from an optically denser medium to a rarer medium, at the interface, this is the interface, this is the interface, right? It is the denser medium, it is the rarer medium. At the interface, it is partially or partly, it is partly, right? So some certain amount of part reflected back into the same medium and partially reflected to the second medium, refracted to the second medium. Certain amount of part reflected back into the same medium, certain amount of part refracted to the second medium. This reflection is called the internal reflection. This reflection is called internal reflection, right? So through this information, he explained what is internal reflection. Till now, we know what is reflection, but now he is using a new word like internal reflection. Okay, right. So what is meant by internal reflection, ma? See here, see this picture, right? So in this picture, it is the surface, it is the point or line which separates both the media, surface or interface which separates both the media. So it is denser medium, it is rarer medium, right? So it is air, it is water, right? Okay. You see the different positions here, ma? It is like O1, O2, name of the points, it is 1 point, O1, O2, O3, O4, like that. So at every point we drew normal, right? And it is the incident ray, like incident ray, right? So it is here refracted ray, but this is reflected ray, this is also reflected ray, right? And it is also reflected ray, okay, right? Now first I want to explain what is internal reflection. See this, when I was explained about refraction, I told you light is a form of invisible energy. When it meets a surface which separates both the media, certain amount of light will get back into the same medium, certain amount of light will go back into the other medium, right? So the amount of light which sent back into the same medium, which comes back into the same medium, is simply called as reflection. Here we are not calling reflection, means it is not the name of certain amount of light energy which came back into the same medium. It is the name of the phenomena, right? When certain amount of light incident at one point, out of that amount, certain amount goes back into the same medium, certain amount goes back into the other medium, means it is a natural phenomena. The name of that phenomena, suppose the phenomena in which light gets back into the same media is called as reflection. The phenomena due to which light will go to the other medium, will enter into the other medium, is called as refraction, right? So name of the phenomena. See, if you see this picture here, you just see only one light, this light ray, right? So it is going from here to there like this, incident at O1. This O1B, O1 is the incident ray, but O1B is the refracted ray. Light is entering from denser medium to rarer medium. But what about O1C? It is reflected ray. It is reflected ray. Okay. So out of this light ray, out of this amount of energy, certain will go into the other medium. It is, we are calling it as refraction. So it is the name of the phenomena. certain amount of light energy came back into the same medium, in the same medium. So that is simply the name of the phenomena is said to be reflection. Okay, right. So this reflection, whatever the reflection took place here, that reflection is called as internal reflection. That reflection is called as internal reflection. Okay, why? Because the light is going from water, that is okay, denser medium, and light is also came back into the same medium. Light also came back into the same medium, right? So that is the reason we are calling it as internal reflection. Internal reflection. Okay, right. Now observe this picture carefully. Here a light ray is going like this, so almost making 90 degrees angle of, okay, here this is the, now it is the interface which separates both the medium. The light ray is going, right? So it is the normal, it is the light ray, means almost angle of incidence is 0. Then according to the laws of reflection, angle of reflection also 0. Okay, so whenever the light goes like this, observe carefully, it retraces the path, right? So it is going back and it is coming back into the same medium like this, right? So it is this you can call it as refracted ray. Next, at point O1, it is the incident ray. Certain amount of light sent back into the, go back into the other medium, which is refracted ray. So here O1B is the refracted ray. O1 is the incident ray, O1B is the refracted ray, O1C is the reflected ray. So it is the angle of incidence and it is the angle of refraction. Okay. Similarly, for next, third or second, from here means second, from here means third. So for the next light ray, it is O2 is the incident ray, right? So this spot, this is called as refracted ray, right? So which is reflected ray, and internally reflected ray, internal reflected ray. Similarly, you go for next one, that is from A to O3. So this is the incident ray, next light ray. If you observe carefully here, the light ray after completion of incidence, the light ray is moving along the interface which separates both the media, right? So the light ray is traveling along the interface which separates both the media. See the arrow mark, right? Okay. Next case, if you see the next light ray here, this is the incident ray and it is the reflected ray, and here is no refraction. So here refraction is present, here refraction is okay, but here the light ray is traveling by touching the surface or interface which separates both the media, right? Here no discussion about refraction, only reflection. Why only reflection? Total amount of energy, total light ray will send back into the same medium. So here is no energy in case of this. In case of here, we have certain amount of light energy here. Here also we have certain amount of light energy, right? Here which touches the interface which separates both the media, but here no refraction, no light energy here. So total light energy, whatever incident here, sent back into the same medium. Okay. Once I request all of you, what is happening from here to there? See this. So light ray is coming to incident, certain amount of light goes back into other medium, so certain amount of sends back into the same medium. Here it is angle of incidence, angle of refraction. It is denser medium, it is rarer medium, right? Okay. You just compare these two. Here, as angle of incidence, you know very well what is Snell's law. Sin I by sin R is equal to constant. Sin I by sin R is equal to constant for one pair of media. Here we are not changing the pair of medium for different light rays. So it is denser medium water, it is rarer medium air. So sin I by sin R is equal to constant, means here mu is constant. Right? So here when we are going to change the angle of incidence, angle of refraction also changes. Okay, right. So in that manner we are changing the angle of incidence, so angle of refraction also changes, means here angle of refraction is coming to increase. Okay, right. But if you say this particular situation here, angle of incidence here at this situation, for this value of angle of incidence, the angle of refraction is 90 degrees. The angle of refraction is 90 degrees. Okay. So the angle of incidence for which angle of refraction is 90 degrees is called as critical angle. Right. The angle of incidence for which angle of refraction is 90 degrees is called as critical angle. So please notice that critical angle is just the angle of incidence. This is also angle of incidence, this is also angle of incidence, this is also angle of incidence. But there is some certain condition, there is some speciality. What is the speciality? The angle of incidence for which angle of refraction is 90 degrees. That is called as critical angle. Okay. So I will tell you in some other manner. Critical angle is the angle of incidence for which angle of refraction is 90 degrees. Angle of refraction is 90 degrees. Okay, right. Still we are going to change the angle of incidence. We didn't stop here. Still we are going to change the angle of incidence. See here. Here the angle of incidence is greater than the critical angle. Here the angle of incidence is less than the critical angle. Here also less than the critical angle. But here angle of incidence is greater than the critical angle. When angle of incidence is greater than the critical angle, there is no refraction. So no light is entering into another medium. Total light, whatever is incident here, comes back into the same medium. This phenomena is called as total internal reflection. So it is total internally reflected ray. This phenomena is called as total internal reflection. Total internal reflection. Okay, right. That is the reason here these and all we call as partially reflected rays. Partially reflected rays. But here total internally reflected ray. So this phenomena is called as total internal reflection. Okay, right. So from here onwards I explained two important definitions. I mean two important words. One is total internal reflection. Another one is critical angle. Another one is critical angle. Right. So it is very important for us to have a clarity when we are going to solve the problems related to critical angle and total internal reflection. From this chapter ray optics, these two things, critical angle and total internal reflection, having lot of importance. So as a board point of view or NEET or mains point of view, these two definitions, and when we are going to solve the problems related to these two, also very important. Okay, right. Next, for the value of I is equal to IC, sin IC is equal to N21, because you know very well N21 is a Snell's law, no? Right. So sin I by sin R. So what is the value of sin 90? 1. Sin 90 is equal to cos 0 is equal to 1. Then you can write this. That is what sin IC is equal to N21 when angle of incidence is equal to critical angle. This is the situation. Okay, right. Next, for values of I larger than IC, so when angle of incidence is greater than critical angle, that I already told you, it leads to the total internal reflection. So that only he is saying here. Snell's law of refraction cannot be satisfied. Okay, so Snell's law of refraction cannot be satisfied. Here no refraction. First of all, the logic behind this information is there is no refraction. When there is no refraction, how can you talk about Snell's law? Because Snell's law is the second law of refraction, that is sin I by sin R is equal to constant, right? So that's why Snell's law become meaningless in case of total internal reflection, and hence no refraction is possible, right? Next, the refractive index of denser medium 1 with respect to rarer medium 2 will be N12 is equal to 1 by sin IC. It is the relation between refractive index and critical angle okay, because you know very well N21 is equal to 1 by N12. Remember the relation between refractive index of one medium with respect to second medium and refractive index of second medium with respect to first medium. So N12, this is right, it is N21, it is N12. N12 is equal to 1 by N21. Okay, so based on that he is writing this one, and R is equal to 90, and N21 is equal to, right, so that is what the Snell's law formula, sin I by sin R, right. Next, some values of critical angle for transparent media. So this is what medium, refractive index and critical angle. So it is water, ground glass, dense flint glass, so different types of glass, and diamond. So these are generally for our observations, right. So these are the refractive index values. For water it is 1.33, and for water critical angle is 48.75, and for crown glass refractive index is 1.52, and for crown glass refractive index is 1.52 and the critical angle is 41.14, and for flint glass, dense flint glass, the refractive index is 1.62 and critical angle is 37.31. Similarly, for diamond, okay, refractive index is 2.42 and critical angle is 24.41. 24.41. Okay, right. Okay, right. So what I am saying is, in this class we concentrated some other applications, some other examples of refraction. At the same time, atmospheric example of refraction, that is what sunrise and sunset. So we discussed the entire natural or whatever it may be, right. So we discussed behind that what's happening, what is the role of refraction regarding these many examples. Next we discussed one example problems. Afterwards, throughout this chapter, two important things. One is total internal reflection and critical angle, that we discussed clearly. Okay ma, right.